An air bubble of volume 1 centimeter cube rises from the bottom of a lake 40 meter deep at a temperature of 12 degrees Celsius. To what volume does it grow when it reaches the surface, which is at the temperature of 35 degrees Celsius? So we will see the solution for this problem. So the volume as given, what is given to us? Volume of air bubble. Air bubble, we will denote it as V1 and it's equals to 1 centimeter cube. So in meter cube it is equals to 1 into 10 raised to power minus 6 meter cube. So as given, the the air bubble rises to height we denote it as D equals to 40 meter, and temperature at depth of 40 meter we denote it as T1 is equals to 12 degrees Celsius. So if we write it in Kelvin, it will be equals to 285 Kelvin. How it is? 273 plus 12 Kelvin. Okay. Now as given, the temperature at the surface of lake, temperature at the surface of lake, and we denote it by T2 is equals to 35 degrees Celsius. Now again we will convert this into Kelvin and it will be equals to 35 plus 273. 35 plus 273 and it will be equals to 308 Kelvin. So the pressure on the surface of lake, what will be? It will, and we denote it by P2, so it will be equals to 1 atm, and that will be equals to 1 into 1.013 into 10 raised to power 5 Newton per meter square, and or you can take it as Pascal. Okay, so the pressure at depth of 40 meter from the surface of lake, it will be equals to, we denote it by P1, and that will be equals to 1 atm plus rho gh. Here rho is the density of water, g is the acceleration due to gravity, and h is the height, or you can take it as depth, and it is equals to 40 meter. So we will substitute, and the value of rho is, where rho is equals to density of water, and that is equals to 10 raised to power 3 kg per meter cube. G is the acceleration due to gravity. Acceleration due to gravity, and its value is equals to 9.8 meter per second square. That's the value of acceleration due to gravity. So therefore the value of P1 will be equals to 1 atm, and 1 atm is equals to 1.013 into 10 raised to power 5 plus rho is 10 raised to power 3, G it is equals to 9.8 into depth, that is 40. After calculating this, the value is equals to 493,300 Pascal. 1 Pascal is equals to Newton per meter square. So now we have T1 V1 upon T1 we have P1 V1 upon T1 is equals to P2 V2 upon T2. So, and here V2 is the volume of air bubble when it reaches the surface of water, and that we have to find. So what is the value, and what will be the V2? It will be equals to P1 V1 upon into T2 upon P2 T1. So we know all the values, and we will substitute all the values here. So P1 was 493300 into V1 is 1 into 10 raised to power minus 6, T2 is 308, and P2 is 1.013 into 10 raised to power 5, and T1 is 285. So we will calculate, and the value is equals to 263 to 5.263 to 10 raised to power minus 6 meter cube, or you can write it as 5.263 centimeter cube, because 1 centimeter cube is equals to 1 into 10 raised to power minus 6 meter cube. So therefore when the air bubble reaches the surface its volume becomes 5.263 centimeter cube, and that's our solution for this question.